This is the summary for lesson 12. So we're going to start with this figure and we're going to go immediately to this slope triangle. So that means that the long side of the slope triangle is along this line. It rests on this line. And this is the horizontal distance and this is the vertical distance. So one of the first things that you can do from that information is figure out the slope. And so that's the vertical distance in this case. And that's this 5 minus this 1, so it's y minus 1. So you can actually mentally replace the 2 with x and the 5 with y. It's the same as this right here. So this is, notice, is y minus 1. So this is 5 minus 1. And so 5 minus 1 is equal to 4. So the vertical length, or the vertical distance, is 4 units along this axis. So notice that when you subtract the 1, 5 minus this 1, or y minus this 1, you're shifting this whole triangle down 1 unit so that it rests along the horizontal axis. So then when you figure out the horizontal distance, this is now on the, or it has been on the y-axis. So the horizontal distance is just going to be the value for x minus 0, because this is already on the y-axis. So that's the same as this 2, which is the x value, minus this 0. 2 minus 0 is 2. So this horizontal distance is 2 units. You go from here, 0, 0, out to this 2. That is 2 units long. So for the horizontal distance, there is no shift because this is already on the y-axis. So the horizontal distance and the x-coordinate are the same thing. That's important as we go through this summary and as we go through these lessons. So I'll say that again. The horizontal distance, this distance of 2 units, because this is starting at the y-axis, is the same as the x-coordinate, 2. So the ratio is the slope. The ratio of the vertical distance to the horizontal distance is 4 to 2. So this is the equation. We'll come back to that. But you're actually using the equation as you go through this right now. But it's 5 minus 1 is 4. 2 minus 0 is 2. That's what we just did in the triangle. So that ratio is equal to 2. So here it is using the coordinates a little bit again. So you're going from 0, 1 to 2, 5. So you're going from 0.01 to 2, 5. So you're going out 2 units along the x-axis and up 5 units from the x-axis along the y-axis. So this is going up 5 units. So you're going from 0, 1 up to 5, 2 this way and then up to here. So you're going over 2 units and up 4 units. So that is the slope, the ratio of 4 to 2. And so what that tells you, well, we'll get to that in a second. So the left side of the expression, you can either use 0, 1 to xy, or if you want to use the numbers, it's 0, 1 to 2, 5. It's the same thing. So the horizontal distance is x minus 0. 2 minus 0 is 2. So that's what the horizontal distance is. Once again, the same as the x-coordinate. But the y, the vertical distance, is y minus 1, or 5 minus 1 is 4. So that's not the same as the y-coordinate. You have to subtract that 1. You have to subtract this 1 right here to get the vertical distance. So y minus 1, once again, this y value minus this 1 is x minus 0 because you're already on the y-axis. So that gets you down to y minus 1 to x, the ratio of y minus 1 to x. That is the equation. So that's the left side of the equation, and we already know that that equals the slope. So what you can say is that the vertical distance is twice the length of the horizontal distance. So this vertical distance, in this case, for this triangle, is 4 units, is twice as long as the horizontal distance, is 2 times as long as the horizontal distance. So the vertical distance, that ratio, is 2 times as long as the horizontal distance. That's what this 2 tells you. Now, if you take those words and turn them into an equation, say it again, the vertical distance is 2 times the horizontal distance. You can rewrite this equation in this form. The vertical distance, y minus 1, is or equals 2 times the horizontal distance. This 2 is the slope. It's right here. So it's 2 times whatever this horizontal distance is. That's going to equal the vertical distance. So now we're going to use this equation to test a point, which is 1123, to see if 1123 rests on this line. So if we've replaced the values for y, 23, and the value for x with 11, and go through this calculation, I'm going to show you this in just a moment. If it equals 2, then that tells you that if you go out 11 units along the x-axis and up 23 units along the y-axis, you will end up on this line. That's a point on this line. All right, so I'm going to replace y. Use this equation up here. I'm going to replace y with 23. So the vertical distance is 22 units. 23 minus 1, you've gone up the y-axis 23 units. But you have to subtract that 1 because that triangle is shifted up 1 unit. So you have to subtract that. So that distance is 22 units. And the horizontal distance is the same as the x-coordinate, which is 11 in this case. So x is 11, and so you just go out 11 units. That's the same as the horizontal distance because this is already at the y-axis. You're just going out 11 units, same as the x-coordinate. So the vertical distance is 22 units. The horizontal distance is 11 units. So that calculation is 2 times. So 22 is 2 times 11. So that tells you that, in fact, this point, 1123, is on the line. So this works. So this finishes the summary that's in the student workbook. And now what I'm going to do is take some time, and I'm going to do this in a separate video. I'm going to take some time and review Activity 3, because the Activity 3 is really pretty important as you go into Unit 3. Because Activity 3 begins to get you to using proportional relationships and understanding what that is, which is the subject of the first 4 lessons of Unit 3. So we'll come back, or I'm going to provide a second video for that right now.